Good morning, everyone. Myself, Dr. Punita Sharma, Associate Professor, School of Basic and Applied Sciences, Maharaja Agrawal University. Today, I will talk about the reaction intermediate generated during the organic synthesis or a chemical reaction in the organic chemistry. So, the content of the lecture will be reaction. What is reaction? Bond fission and its types, and the reaction intermediates. First of all, reaction or a chemical reaction or a synthesis reaction is defined as the formation of the some product starting from one or more compound. So here you can see there two reactants which are the starting material react together under a particular substances to give us a product A B. Simplest example for this is the sodium chloride, which we call common salt, used daily in our life. In this, reactants are sodium and chlorine. They come up together to make NaCl, common salt. So during a chemical reaction, their following processes are possible. There may be the bond formation or breaking of any bond. There is the rearrangement of atom around a particular carbon or the group of atoms around a particular atoms. There it also involves the transfer of electron from one atom to the another atom depending upon the nature of bond breaking and bond forming process. These formation has been possible. So during an organic reaction, if we want to categorize this reaction, we will simply or broadly classify them single step reaction in which the whole reaction is completed in a single step, and other one is the two or more step reaction or multiple reaction. Your reaction will be completed in the more than one step. For example, we say formation of carb in the photocatalytic reaction. First of all, there is the generation of free radical or reactive reaction intermediate. Then there is the progression of the chain, which we also call chain progress propagation, and then the termination of reaction. So the in the photoanalytical reaction, it involves the three steps. So it comes under the multiple step reaction. Now we will, during the reaction, we said a bond will be formed, or either it break down or it will be formed. During this process, the formation of the bond in the formation of bond, there is two electron involved, which has been shared by the two atoms. But during the bond breaking, which is also known as bond fission, there is the formation breaking of bond. So the breaking or making of the bond will take place by two ways, either with the help of homolysis or with the heterolysis. And now we will talk about the homolytic fission. Homolytic fission is a type of fission in which shared electron pair is distributed equally between the two bonded atoms. Here we can see that A and B bond will be break down into the A and B, and each having one electron with themselves, which are we will call them A free radical and the B free radical. So normally high temperature light or photolytic reaction or peroxides are used for the homolytical phasor. Here you can see that this reaction transfer or migration of electron has been represented by the single-headed arrows. Now heterolytic fission. In the heterolytic fission, as the name suggests, there is the unequal distribution of the electron. In this case, two active the bond when the bond will broke, two species has been formed. One is the electron deficient, which is positively charged, and another is the electron efficient, which is negative charged. So in the heterolytic fission, electron will not divide equally after bond cleavage. In the heterolytic level fission, there is the generation of carbocation and carbanion. on the basis of their the electronegativity difference between the two atoms within the compound. Then here we can see if our compound say B is more electronegative than A, then during electrolysis A will be positively charged and B will be the negatively charged. For example of the we will take the alkyl chloride. In this, the chlorine will be had taken two electron with itself, and there is a generation of electron deficient carbocation. In the second case, if A is more electronegative, then A will get the two electron of the shared pair with itself, with, left the B electron deficient. Here you can see in this reaction there is the generation of carbonic anion. Then the reactant, when we will talk about the reactive intermediate, there is few parameter which has to be used for the to define the reaction intermediate. The reaction intermediate's lifetime appreciably longer than the molecular vibration. They are formed directly or indirectly from the reactant, and they will be converted into the product. So we will conclude it like that the reactive intermediate must be very reactive, but they should also possess some stability. The common feature which we will out in the reactive intermediates are they formed in the low concentration, having unusual valence stage, highly reactive, have some stability through resonance formation, can be monitored using the spectroscopical measurements. Organic reaction intermediates are basically, we will divide broadly them into electrophile and the nucleophile. Electrophile, as the name suggests, they are electrophiles, means electron living. We suggest that they are electron deficient species and attack on the center which has maximum electron density, or they are or which are negatively charged. They are the Lewis acid. Electrophiles are of two types: positive electrophiles and the neutral electrophiles. Proton, hydronium ion, and all the carbocation comes under the under the category of positive electrophile, which carries positive charge. Then we will talk about the nucleophile. Nucleophile are the negatively charged species. They are rich in electron and they attack at the center of minimum electron density. So they will attack on the positively charged molecule. They will act as a Lewis space. Like the electrophile, they are of two types, negative and neutral. Neutral species like water and ammonia will act as a neutral nucleophile, while all the carbocation, hydroxyl ion, chloride ion, which carries the negative charge, will act as a negative nucleophile. Now, free radical. As we know that during the heterolytic reaction or fissions, there is a generation of free radical. They are the neutral species, contain unpaired or odd number of electron in their valence shell. So free radicals are paramagnetic in nature, and they are important reactive intermediate, has been used for the synthesis of many biological and physiological important compounds. The free as we will talk about the geometry of the radical, if the carbon having free odd electron have sp2 hybridization, then the structure will be the planar. If the carbon having odd electron will have sp3 hybridization, it will show the pyramidal symmetry. Then there are the type of free radical: alkyl free radical, allyl free radical, and the benzyl free radicals. Now, carbocation, they are also known as carbonium ion. They are the positive charged species. Carbon is trivalent in nature, shows sp2 hybridization, and has the planar symmetry. They are formed by the hydrolytic cleavage of carbon and oxygen, carbon and nitrogen. After the cleavage, if the carbocation is formed, the two electron of the bond must go to the other atom. So there are the type of carbocation like carbonyl. They are alkyl, allyl, and benzylic carbocations. Carbanions are basically species containing unshared pair of electrons at the carbon atoms. Here we can see it has sp3 hybridized atom, and it has long pair of electron, and the geometry of this is the pyramidal. So carbon will act as a nucleophile. It has 8 electrons in its outermost shell. It is formed as a result of hydrolysis. So now we will talk about the carbons. Carbons are the natural neutral substances. This is the structure of carbon. It is classified into the triplet carbon or the singlet carbon on the basis of the pairing of electron on the p orbital. They are the divalent compound. They are very reactive, and they are differentiate or classified on the basis of the spin of the electron arrange themselves on in the p orbital. They have very brief lifespan, and carbons are most often made from the dialkenes, photolytic and thermo transition methods. Now the nitrines, like they are the analogs of carbons. They are also known as imines. Nitrogen atom is uncharged and univalent. This is the structure of nitrines. Like the carbons, they are also classified as a singlet and the triplet nitrines. They are unstable form of the nitrogen gas with the pyramidal structures. Now, arenes. Arenes are the highly reactive chemical species derived from the aromatic ring by the removal of two substituents. They are very electrophilic in nature, and they are typically generated using the strong base or the fluoride source. Thank you. That's all about the reaction intermediate.